Welcome back to the Math and Physics Resource Center online from Saginaw Valley State University. My name is Amanda, and today we're going to be looking at Calculus 3, Math 261, evaluating double integrals with polar coordinates. Today we're going to be looking at the example of the function f of xy equals x plus y, and that's going to be within the region of r theta 1 is less than or equal to r, less than or equal to 2, and where pi over 2 is less than or equal to theta is less than or equal to 3 pi over 2. So this here is establishing the region that it's going to take place within. That's going to give the bounds of that integral. And that is going to look like, it's going to go from pi over 2, which is located right here, to 3 pi over 2, which is down here. So look at that. And it's going to have a radius of 1. So we'll call this 1 to a radius of 2. So it's going to create like a donut. And this is the region we're working within. So now let's set up the integral. Well, in order to set the integral, first we need to convert this to polar coordinates. So in order to find the integral, first we need to convert this to polar coordinates so we can work within these bounds. So the polarized form of this function is going to look like f of r theta equals r cosine theta plus r sine theta. Because we know x is r times cosine theta and y is r sine theta, which is a known value when working with polar coordinates. So now, to create the double integral, it's going to be of the function xy dA. So now we're going to set up the integral, keeping in mind that dA equals r dr d theta. So we're going to go on the integral r cosine theta plus r sine theta, and that's going to be on so now we're going to be looking at the double integral of r cosine theta plus r sine theta. That's b times r dr d theta. So our bounds r are going to be 1 to 2, and our bounds theta are going to be pi over 2, 3 pi over 2. So now we're going to solve out the integral. So in order to solve it out, we're going to take out all the r's. So it's going to be r squared times cosine theta plus sine theta. So now when we take dr, we can get rid of anything with theta in it because it's considered a constant currently. So we can pull it out and put it over here. That's b times cosine theta plus sine theta, and that's going to be from 1 to 2, r squared dr d theta. Now we're going to integrate in terms of r. So we're going to be integrating this section right here. So when we do that, it's going to be r cubed over 3 from taking the antiderivative. That's going to be from 1 to 2. Don't forget that our outer bounds are still going to be there. So our d theta, cosine theta plus sine theta, and the integral pi over 2 to 3 pi over 2. So now if we solve this out, it's going to be 2 cubed over 3 minus 1 cubed over 3. And again, everything else is going to stay consistent. 2 cubed over 3 minus 1 cubed over 3. That comes out to be 7/3, which is constant, so we can put it in front. So we're going to end up with 7/3 times pi over 2 to 3 pi over 2 of cosine theta plus sine theta d theta. So now we're going to take the antiderivative of cosine theta plus sine theta, which comes out to be sine theta plus, well, it's not going to be plus because the antiderivative of sine theta is negative cosine theta. And that's all going to be from pi over 2 to 3 pi over 2. And it's going to be times 7/3. So now you're going to have 7/3 times sine of 3 pi over 2 minus cosine of 3 pi over 2. And that's going to be minus sine pi over 2 and minus a negative cosine theta, so plus cosine of pi over 2. And that all comes out to be 7/3 times. So this comes out to be sine pi over 3 pi over 2, that's -1. Cosine 3 pi over 2, that's 0. Sine pi over 2, that's going to be +1. And cosine pi over 2, that comes out to be 0. So it's going to be -1 minus 1, so it's going to be -2. And that's going to come out to be -14/3. Thank you for watching this video from Math and Physics Resource Center online from Saginaw Valley State University.